All right, let's talk HACCP, hazard analysis and critical control points. Think of it as a superpowered, proactive food safety system. HACCP isn't about just reacting to problems after they happen, like traditional inspection methods that spot check for contamination. Instead, HACCP is about preventing those problems in the first place. It's like designing a car with built-in safety features before it ever hits the road. HACCP gained prominence in the 1960s, driven by NASA's need for fail-safe food for space missions. They needed absolute certainty, so they pioneered this systematic approach. Unlike traditional test and destroy methods that only catch issues in sampled batches, HACCP analyzes the entire food production process, from raw ingredients to finished product. Every step is scrutinized to identify potential hazards. This proactive approach ensures food safety is built in, not just tested for. All right, let's dive into the first preliminary step of HACCP, assembling the HACCP team. This isn't just grabbing whoever's free, it's about strategically building a multidisciplinary force. Think of it like assembling the Avengers, but for food safety. You need expertise from different areas. Quality assurance is crucial, of course. They're the guardians of standards and regulations. Production folks bring invaluable knowledge of the process itself, what happens, where, and when. Maintenance is vital because equipment malfunctions can introduce hazards. But don't stop there. Depending on your product, you might need someone from sanitation, engineering, or even microbiology. For example, if you're dealing with canned goods, a thermal processing specialist is essential to ensure adequate sterilization, following something like F equals D times log of A minus log of B to ensure appropriate lethality rate. The key is diverse knowledge to cover all potential hazards. This team approach ensures a comprehensive and robust HACCP plan. All right, let's dive into preliminary step 2, describing the product. This isn't just about slapping a label on something. It's a thorough breakdown. Think of it as the foundation for your entire HACCP plan. First, the ingredients. List everything, every spice, every additive. Next, the physical and chemical properties are crucial. We're talking pH, water activity, that's AW, not just W, viscosity, anything that could influence hazard growth or survival. For example, a low pH can inhibit bacterial growth. Then, shelf life. How long is the product safe and palatable? This directly affects storage and distribution. Speaking of which, detail the packaging. Is it vacuum sealed? Modified atmosphere? And how will it get to the consumer? Refrigerated trucks? Ambient storage? Think about canned goods versus fresh produce. Canned goods have a low water activity, extending shelf life. Fresh produce? High water activity, short shelf life, and usually requires refrigeration. A complete product description ensures you're controlling the right hazards for the right reasons every single time. Okay, so you've got your product and your team, but who's actually eating this thing? Identifying the intended use is crucial because food safety needs change depending on the consumer. Think about it. What's safe for you and me might be dangerous for someone else. For example, the general public usually has a robust immune system, but infants, the elderly, and immunocompromised individuals are more vulnerable. That's why products intended for babies, like infant formula, have super strict safety standards, like pathogen limits of 0 CFU per gram. Similarly, unpasteurized milk or juices might be fine for some adults, but they pose a serious risk to pregnant women and young children due to bacteria like Listeria or E. coli. So knowing who will consume the product dictates the level of rigor needed in your HACCP plan, impacting everything from ingredient sourcing to processing and even packaging. All right, let's dive into creating a process flow diagram. Think of it as your food safety roadmap. It's a visual representation of every step your product takes, from raw materials arriving at your door to the final product shipping out. To build one, start with a simple box representing raw material receiving. Then add boxes for each step: storage, preparation, cooking, cooling, packaging, and dispatch. Each box should clearly label what happens, for example, chicken thawing or spice mixing. Use arrows to show the direction of the product flow. Be meticulous. Include every step, even seemingly small ones like metal detection or weighing ingredients. Accurate diagrams are essential, so grab your team, walk the production floor, and verify that your diagram perfectly matches reality. This on-site confirmation is crucial. It's the foundation for identifying potential hazards later on. All right, so we've built our process flow diagram. Now comes a crucial step, on-site verification. Think of it as fact-checking your map against reality. This isn't just a casual glance. We're talking a walkthrough, step by step, comparing the diagram against what actually happens on the plant floor. Are the steps in the right order? Are all the pieces of equipment accounted for? Are there any undocumented procedures, like temporary fixes or shortcuts, that have become routine? Discrepancies are common. Maybe a piece of equipment was moved or a step was added. The key is to document everything. Update the flow diagram immediately to reflect the accurate process. This verified diagram forms the foundation of your entire HACCP plan, so accuracy is paramount. It's better to find and fix errors now rather than facing a food safety issue down the line. All right, let's dive into hazard analysis, Principle 1 of HACCP. This is where we become detectives, hunting down potential dangers in our food production process. First, define a hazard. We're talking about three main types: biological, like bacteria and viruses; chemical, such as toxins or allergens; and physical, think metal shards or glass. Now, how do we find these hazards? Simple. Systematically analyze each step of your process flow diagram. Imagine you're making soup. Start with raw ingredients. Are there potential bacterial contaminants in the vegetables? Then consider the cooking stage. Could improper heating lead to bacterial survival? Next, think about packaging. Could the packaging material leach chemicals into the soup? It's all about asking what if at each stage and documenting every potential hazard you uncover. This thorough analysis is the foundation of your entire HACCP plan. All right, let's pinpoint those critical control points, or CCPs. These aren't just any control point. They're the key places where you absolutely must control a hazard to prevent, eliminate, or reduce it to an acceptable level. Think of it like this. A regular control point might be ensuring your fridge is generally cool, but a CCP is ensuring the precise internal temperature of that chicken you're cooking to kill salmonella. Take cooking, for example. Achieving a specific internal temperature for a set time, say 75 degrees Celsius for 2 minutes, is a CCP for eliminating bacteria. Or consider metal detection. Running your product through a metal detector right before packaging is a CCP to prevent physical hazards from reaching consumers. So how do we find them? A decision tree helps. It's a series of questions like, does this step eliminate the hazard? If yes, it's a CCP. If not, is contamination likely to occur beyond acceptable levels? The answers guide you. Remember, identifying CCPs accurately is vital for an effective HACCP plan. All right, let's talk about setting critical limits, the third of the 7 HACCP principles. Think of these limits as your do not cross lines for food safety. They're measurable, meaning we can actually test them, to ensure a CCP is under control. For example, if we've identified cooking as a CCP to kill salmonella in chicken, our critical limit might be cook to an internal temperature of 165 degrees Fahrenheit, 74 degrees Celsius, for 15 seconds. Both the temperature and the time are crucial. Another common example is refrigeration. Maintain a refrigeration temperature below 40 degrees Fahrenheit, 4 degrees Celsius, to prevent bacterial growth. These limits aren't pulled out of thin air. They're based on scientific data, regulatory standards, and expert advice. Different products and processes will require different critical limits. For instance, pH levels are crucial for controlling the growth of certain bacteria in acidified foods. So establishing the right critical limits is key to preventing hazards. All right, let's nail down the final 4 HACCP principles. First, monitoring procedures. Think of it as quality control's watchful eye. It's how you track your critical limits: temperature, time, pH, when you do it, and who's responsible. Example, checking the internal temp of cooked chicken every 15 minutes. Next, corrective actions. Things go wrong, right? This principle is about having pre-planned steps to fix deviations. If that chicken temp drops too low, what do? Increase cooking time? Discard the batch? Document it all. Then, verification. It's more than just monitoring. It's about confirming your entire HACCP system works. This includes things like independent lab tests, reviewing records, and auditing the whole process. It's like a second opinion for your food safety plan. Finally, record keeping. If it's not written down, it didn't happen. Keep detailed logs of monitoring, corrective actions, verification activities, everything. These records are your proof of compliance and crucial for continuous improvement. HACCP's real impact? Safer food for everyone.